morning, students. So today we shall go ahead with the 35th session, and this is going to be in states of matter. In today's class we are going to discuss regarding Maxwell Boltzmann distribution, laws of molecular velocity and molecular energy. In today's class we are going to discuss Maxwell Boltzmann distribution, laws of molecular velocity and molecular energies. Coming to first Maxwell Boltzmann distribution, law of velocities. On the basis of the law of probability, Maxwell calculated the fraction of molecules having velocity between c and c plus dc is given as the probability. Based on the law of probability, Maxwell calculated the fraction of molecules having velocity between c and dc as d and c by n is equal to 4 pi m by 2 pi rt to the power of 3 by 2 e to the power of mc square by 2 rt c square dc. Let us number this as equation 1. Here d and c is going to be the number of molecules having velocity between c and dc. Here d and c is the number of molecules having velocity between c and c plus dc out of total n molecules of the gas, and m and t are the molecular weight and absolute temperature of the gas respectively. Making a small rearrangement by bringing this dc over here, I can write the same expression as 1 by n dnc by dc is equal to 4 pi m by 2 pi rt to the power of 3 by 2 e to the power of mc square by 2 rt c square, and numbering this as equation 2. This term 1 by n dnc by dc is called as the probability p of finding molecules with velocity c. So if we are going to plot a graph between the speed and the frequency density, this is going to be the curve which we are going to get. That is, this is going to be the probability, that is 4 pi m 2 pi kbt, that is going to be the, this is Boltzmann constant to the power of 3 by 2. This is going to be v or c square e to the power of minus mc square by 2 kbt. So the area under the whole curve is equal to, the area under this whole curve is equal to the total number of molecules. This is going to be the area under this curve is going to be the total number of molecules, and the height of this ordinate corresponds to any velocity which is measured as the fraction. So this height is going to give me the fraction of the molecules which is going to have that velocity. Now this area is going to be the graph which represents the percentage of particles corresponding to the speed range. The speed range is going to be between 1300 to 1600 meter per second. So this is going to give me the percentage of particles in the corresponding speed range. Next, coming to Maxwell distribution of energy. On the basis of law of probability, we know the equation or the fraction of molecules having velocity between c and c plus dc is given by 1 by n dnc by dc is equal to 4 pi m by 2 pi rt to the power of 3 by 2. This is equal to e to the power of mc square by 2 rt c square. This term is called as probability of finding the molecule with velocity c. The distribution of velocities, this distribution of velocities can be converted to distribution of energies as, here this 1 by 2 mc square, 1 by 2 or mc square by 2, this term can be made as energy, that is going to be the energy. So this term can be replaced by the term E. The kinetic energy of the gas per mole is going to be 1 by 2 mc square is equal to E. So substituting instead of 1 by 2 mc square as E, the equation is going to be represented as, likewise DC also, DC is going to become equal to, that is P dash will be equal to 1 by n dNc by dE. Now this is going to be dE. 2 pi by pi RT to the power of 3 by 2 e to the power of minus e. This is replaced e to the power of minus ERT into e to the power of 1 by 2. P represents the probability of molecules having energy E. Next is effect of temperature on Maxwell distribution of velocity. To check the effect of temperature on Maxwell distribution of velocities, we know with increase in temperature, the value of most probability increases. With increase in temperature, the value of most probable velocity, is going to increase. Then the fraction of molecules possessing most probable velocity decreases with increase in temperature. The fraction of the molecules possessing most probable velocity is going to decrease with increase in temperature. So this is going to be the effect of temperature. So in today's class we had studied the Maxwell's distribution law of molecular velocities and Maxwell distribution of relation of molecular energy. So Maxwell distribution law for velocity is going to be represented as 1 by n dNc by dc is equal to 2 pi m by 2 pi RT to the power of 3 by 2 e to the power of mc square by 2 RT c square. This is going to be for Maxwell distribution law of velocity, and Maxwell distribution of energy is given as P dash is equal to 1 by n dNc by dE is equal to 2 pi by pi RT to the power of 3 by 2 e to the power of minus e RT e to the power of 1 by 2. And effect of temperature on Maxwell distribution of velocities. With increase in temperature, the value of most probable velocity increases and the fraction of molecules possessing most probable velocity increases with increase in temperature. Okay, thank you.